z equal to f of 2x plus 3y plus y into g of 2x plus 3y, right? Consider as equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of the equation, or you can do directly. It's not necessary to write dou by dou x on both sides of the equation, okay? Just to avoid error, I'm writing it. Right, now this gives us dou z by dou x equal to, here we are partially differentiating with respect to x, so we'll treat y as constant, okay? Now the partial derivative of f of 2x plus 3y is f dash of 2x plus 3y into inner derivative, that is dou by dou x of 2x plus 3y plus partial derivative of y. Here y is treated as constant since we are partially differentiating with respect to x, right? So constant into partial derivative of g of 2x plus 3y is g dash of 2x plus 3y into inner derivative, that is dou by dou x of 2x plus 3y. Since we know that dou z by dou x can be replaced by the notation p, we'll just replace it by p. We'll get p equal to f dash of 2x plus 3y into 2 into partial derivative of x with respect to x is 1 plus partial derivative of 3y with respect to x is 0 plus y into g dash of 2x plus 3y into partial derivative of 2 times partial derivative of x with respect to x is 1 plus partial derivative of 3y with respect to x is 0. This gives us p equal to 2 into 1 2, 2 plus 0 2, 2 into f dash is 2f dash, 2 into f dash of 2x plus 3y plus 2 into 1 2, 2 plus 0 2, 2 into y 2y into g dash. Now consider this equation as equation number 2. See, this equation involves p. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1. Okay. Here we are partially differentiating with respect to 1, so we'll treat x as constant. Just apply dou by dou y on both sides of 1 to avoid error. Okay. Or you can do directly. This gives us dou z by dou y equal to partial derivative of f of 2x plus 3y with respect to y is f dash of 2x plus 3y into inner derivative, that is dou by dou y of 2x plus 3y plus, here you have y and g of, right? So we are going to apply uv whole prime formula, that is u prime v plus v prime u, g of 2x plus 3y into partial derivative of y with respect to y plus y into partial derivative of g of 2x plus 3y. Okay. Since we know that dou z by dou y can be replaced by the notation q, so you'll get q equal to, since dou z by dou y equal to q, we'll get q equal to f dash of 2x plus 3y into partial derivative of 2x with respect to y is 0 plus 3 into partial derivative of y with respect to y is 1 plus g of 2x plus 3y into partial derivative of y with respect to y is 1 plus y times partial derivative of g of 2x plus 3y is g dash of 2x plus 3y into inner derivative dou by dou y of 2x plus 3y, right? This gives us q equal to 3 into 1 3, 3 plus 0 3, 3 into f dash is 3 f dash, that is 3 into f dash of 2x plus 3y, right? Plus g of 2x plus 3y into 1 is g of 2x plus 3y plus y times g dash of 2x plus 3y into partial derivative of 2x with respect to y is 0 plus 3 times partial derivative of y with respect to y is 1. And this gives us q equal to 3 times f dash of 2x plus 3y plus g of 2x plus 3y plus y times, or 3 into 1 3, 3 plus 0 3, 3 into y 3y into g dash. Consider some equation number say 3 which involves q. We know that r is nothing but dou square z by dou x square, or we can write this as dou by dou x of dou z by dou x. Since dou z by dou x is nothing but p, right? Or we can just replace it by the notation p. So partial derivative of p with respect to x gives r, or we can say that just pick the equation involving p. This is the equation involving p. Now partially differentiate it with respect to x to get equation involving r. Okay, right? Now what we are going to do is we'll partially differentiate 2 with respect to x. We know that p is nothing but dou z by dou x, right? Instead of writing p, we can write dou z by dou x, or you can just write p itself. There is nothing wrong in it. But I'll take dou z by dou x instead of p. Now partially differentiating 2 with respect to x. Just apply dou by dou x on both sides of this equation. This gives us dou square z by dou x square equal to 2 into partial derivative of f dash of 2x plus 3y is f double dash of 2x plus 3y into inner derivative, that is dou by dou x of 2x plus 3y plus 2 into y is also treated as constant here, right? So let's write 2y into partial derivative of g dash with respect to x is g double dash of 2x plus 3y into inner derivative, that is dou by dou x of 2x plus 3y, right? This gives us, since dou square z by dou x square equal to r, so we'll replace it by r. We'll get r equal to 2 into f double dash of 2x plus 3y into 2 times partial derivative of x with respect to x is 1 plus partial derivative of 3y with respect to x is 0 plus 2y into g double dash of 2x plus 3y into 2 times partial derivative of x with respect to x is 1 plus partial derivative of 3y with respect to x is 0. This gives us r equal to 2 into 1 2, 2 plus 0 2, 2 2s are 4. So you'll get 4 f double dash of 2x plus 3y plus 2 into 1 2, 2 plus 0 2, 2 2s are 4, 4y into g double dash of 2x plus 3y. Consider as equation number 4. So this equation involves r. Now let's find equation involving t. Okay, you know that t is nothing but dou square z by dou y square. We can write this as dou by dou y of dou z by dou y. Since dou z by dou y is nothing but q, so we'll get dou q by dou y. Dou q by dou y is a t, right? Now pick the equation involving q. So this is the equation involving q. Now partially differentiate it with respect to y. Partially differentiate this equation with respect to y to get equation involving t. Now what we are going to do is we'll just partially differentiate equation 3 with respect to y. Okay. Partially differentiating 3 with respect to y. Let's write dou z by dou y instead of q, okay? Now, we'll partially differentiate both sides of this equation with respect to y. Right. Just apply dou by dou y on both sides of the equation. You'll get dou by dou y of dou z by dou y equal to dou by dou y of 3 into f dash of 2x plus 3y plus g into 2x plus 3y plus 3y into g dash of 2x plus 3y. This gives us dou square z by dou y square equal to 3 into partial derivative of f dash with respect to y is f double dash of 2x plus 3y into inner derivative dou by dou y of 2x plus 3y plus partial derivative of g with respect to y is g dash of 2x plus 3y into inner derivative dou by dou y of 2x plus 3y plus 3 into, you have y and g dash, right? You can apply uv whole prime formula. So I'll get g dash of 2x plus 3y into partial derivative of y with respect to y plus y into partial derivative of g dash with respect to y. This gives us, since dou square z by dou x square equal to t, dou y square equal to t, just replace it by t, you'll get t equal to 3 into f double dash of 2x plus 3y into partial derivative of 2x with respect to y is 0 plus 3 times partial derivative of y with respect to y is 1 plus g dash of 2x plus 3y into partial derivative of 2x with respect to y is 0 plus 3 times partial derivative of y with respect to y is 1 plus 3 times g dash of 2x plus 3y into partial derivative of y with respect to y is 1 plus y times partial derivative of g dash with respect to y is g double dash of 2x plus 3y into its inner derivative, that is dou by dou y of 2x plus 3y, right? Which gives us t equal to 3 into 1, 3 plus 0, 3 3s are 9, you'll get 9 f double dash of 2x plus 3y plus 3 into 1, 3 plus 0, 3 into g dash is 3g dash plus 3 times g double dash into 1, g dash into 1 is g dash, that is g dash of 2x plus 3y, right, plus y times g double dash of 2x plus 3y into partial derivative of 2x with respect to y is 0 plus partial derivative of 3y with respect to y is 3 into 1, that is 3, right? 3 into partial derivative of y with respect to y is 1 otherwise, right? Now this gives us t equal to 9 into f double dash of 2x plus 3y plus 3g dash of 2x plus 3y plus 3g dash of 2x plus 3y. Here you'll have 3 into 1, 3 plus 0, 3 into g dash is 3g dash, 3g double dash into y is 3yg double dash. 3yg double dash into this 3 gives 9y g double dash. Okay. 3 into first term, 3 into second term, simply. Fine. Now this results to t equal to 9f double dash of 2x plus 3y plus 3g dash plus 3g dash gives 6g dash of 2x plus 3y plus 9y g double dash of 2x plus 3y. Consider as equation number 5. So this equation involves t. Now observe the equations we have. See, in equation R we have 4f double dash plus 4y g double dash. Here you have f dash g y g dash, f dash and g dash. Here you are having f double dash g double dash, right? So we can replace f double dash plus y into g double dash using equation 4. But what about g dash? We need some value for g dash, right? So the equations we have is not enough to find the required partial differential equation, so that we'll find equation involving s. We know that s is nothing but dou square z by dou x dou y, right? We can write this in two ways. You can just write this as dou z, dou by dou x of dou z by dou y, or dou by dou y of dou z by dou x, right? We know that dou z by dou x is nothing but p, and dou z by dou y can be replaced by q. So you'll get dou by dou x of q here, which gives dou q by dou x, or you'll get dou p by dou y. Dou p by dou y is nothing but s, or dou q by dou x is nothing but s. So if you want to find equation involving s, we have to use any of these two. If you want s using equation involving p, use this. Just consider equation involving p and partially differentiate it with respect to y, so that you'll get equation involving s. Or if you want to find equation involving s using q, use equation involving q and partially differentiate it with respect to x, so that you'll get equation involving s with the help of equation involving q. So let's go for the first one. Let's partially differentiate equation 3 with respect to x. Okay, just apply dou by dou x on both sides of equation 3. This gives us dou square z by dou x dou y equal to, here we are partially differentiating with respect to x, so we'll treat y as constant. Partial derivative of f dash with respect to x is f double dash of 2x plus 3y into inner derivative dou by dou x of 2x plus 3y plus partial derivative of g of 2x plus 3y is g dash of 2x plus 3y plus 3y into partial derivative of g dash with respect to x is g double dash of, here you need to write inner derivative, right? You'll get into partial derivative of 2x plus 3y, inner derivative, g dash into its inner derivative plus 3y into partial derivative of g dash is g double dash of 2x plus 3y into its inner derivative dou by dou x of 2x plus 3y. Okay, right. Since dou square z by dou x dou y equal to s, replace the LHS by the notation s, you'll get s equal to 3 into f double dash of 2x plus 3y into partial derivative of 2x with respect to x is 2 plus partial derivative of 3y with respect to x is 0 plus g dash of 2x plus 3y into partial derivative of 2x with respect to x is 2 plus partial derivative of 3y with respect to x is 0 plus 3y into g double dash of 2x plus 3y into partial derivative of 2x with respect to x is 2 plus partial derivative of 3y with respect to x is 0. Actually, you'll write 2 into partial derivative of x with respect to x is 1. You can write like this better. It's 2 into 1. 2 into 1. You can write directly. There is nothing wrong in it. Right. This gives us s equal to 2 into 1, 2, 2 plus 0, 2, 2 3s are 6. We'll get 6 f double dash of 2x plus 3y plus 2 into 1, 2, 2 plus 0, 2, 2 into g dash plus 2 into 1, 2, 2 plus 0, 2, 2 3s are 6. You'll get 6y g double dash. Consider as equation number 6. Now we have equation number 4, r equal to 4 into f double dash of 2x plus 3y plus 4y into g double dash of 2x plus 3y, right? Just take 4 common, you'll get 4 times f double dash of 2x plus 3y plus y into g double dash of 2x plus 3y. Now divide both sides of the equation with 4. You'll get r by 4 equal to f double dash of 2x plus 3y plus y into g double dash of 2x plus 3y, right? From this we can say that, or we can just write the same thing as f double dash of 2x plus 3y plus y into g double dash of 2x plus 3y equal to r by 4, right? So here we got one equation. We can use this for later. Now to find the value of g dash, we can use either 5 or 6. Let's take 6 or 5, whatever. Okay, let's take 6, that is s equal to 6 into f double dash of 2x plus 3y plus 2 into g dash of 2x plus 3y plus 6y into g double dash of 2x plus 3y. Okay, we have equation 6, right? Fine. We'll get s equal to, now take 6 common from these two terms. We'll get 6 times f double dash of 2x plus 3y plus y into g double dash of 2x plus 3y plus 2 into g dash of 2x plus 3y. So already we have f double dash plus y into g double dash value, which is r by 4. Just replace this using r by 4. We'll get s equal to 6 into r by 4 plus 2 into g dash of 2x plus 3y. If you want, you can simplify it or leave it like this. Now you can bring this term to LHS. You'll get s minus 6 times r by 4 equal to 2 into g dash of 2x plus 3y. Now divide both sides of the equation with 2. You'll get 1 by 2 into s minus 6 times r by 4 equal to g dash of 2x plus 3y. Okay, fine. Now we got the value of g dash, that is g dash equal to g dash, right? G dash of 2x plus 3y equal to 1 by 2 times s minus 6 times r by 4. Let's write as 3 r by 2, or you can simplify it. Okay, now consider equation number 5. We have already used equation 4, equation 6. And now we are going to use equation number 5. We have equation 5. Now use equation 5. T equal to 9f double dash of 2x plus 3y plus 6g dash of 2x plus 3y plus 9y into g double dash of 2x plus 3y. Let's take 9 common from these two terms. We'll get 9 times f double dash of 2x plus 3y plus y into g double dash of 2x plus 3y plus remaining term 6 g dash of 2x plus 3y. Okay, fine. What we are going to do is just replace f double dash plus y into g double dash using r by, just replace it by r by 4. We got this using equation 4, okay, plus 6 into, replace the value of g dash, which is 1 by 2 into, simplify it here itself, okay, 2s minus 3r by 2. Right, this gives us t equal to 9r by 4 plus 3 2s are 6s minus 3 3s are 9r by 2. Now take the LCM of 4 and 2. Which is 4. You'll get 4 into in the denominator of the first term you have 4, close 4. So you'll get just 9r. You don't multiply anything to this numerator. And if you observe the second term, you have 2 in the denominator, just close this 2. You have one more 2, right? Just multiply this 2 to this numerator. You'll get 2 6 are 12s, 2 9s are 18r. Okay. Now multiply both sides with 4. You'll get 4t equal to, or just bring this 12h's. You'll get 4t equal to 12s minus 18r plus 9r gives minus 9r, right? Which gives the required equation. You can just write this as 9r minus 12s plus 4t equal to 0, or 9 into dou square z by dou x square, since r is nothing but dou square z by dou x square, minus 12 into s is nothing but dou square z by dou x dou y, plus 4 into dou square z by dou y square equal to 0, which is the required solution. Okay. Which is the required partial differential equation.